Hello all, welcome to the lecture Additive Manufacturing and its Applications. This video we are going to see a solid based additive manufacturing process. Let us go into the slides. So wire arc additive manufacturing is one of the solid based additive manufacturing techniques. In wire arc additive manufacturing, the metals are deposited layer by layer on each other by the application of a robot arm. So a welding robot is integrated with a power source where a welding torch melts the wire feedstock to build the 3D parts. So this is otherwise called as gas metal arc welding. So it is by the application of a robot, and it is a technique where the direct energy deposition family. So this technique belongs to the direct energy deposition family. So this is the schematic diagram of the wire arc additive manufacturing. If you see the schematic diagram, you can see the computer controlled robot, the wire feeder, that is the raw material, and the next thing is the GTAW source, this gas tungsten arc welding source. Uh, the shielding gas is provided in the cylinder, and there is a robot that is a 6-axis robot. So this robot arm moves according to the program generated by the computer control. So this robot arm welds or deposits the metals on layer by layer according to the given instruction by the computer. So in this robot arm we can see the wire feeding part, and the next thing is the electrode, that is a tungsten part. So the materials are deposited on the welding table, and the table moves in the Z direction, that is the vertical direction. The robot arm moves in the X and Y direction, depends upon the geometry of the material or the model. This is the another schematic diagram. You can see here the shielding gas is used in this technique in order to prevent the reaction of the gases that are present in the environment. So while welding the gas tungsten or welding, there is a chance of the reaction with the gases that are present in the environment. So that is why there is a shielding gas that is provided during this operation. So we can see here. So this is how the directional movement is achieved. So the printing head, that is the robot arm, the mechanism that can move in the different axis, whereas the table is only move on the direction that is vertical direction. In some cases the table will not move, only the robot arm moves according to the profile. So here the wire feed is the metal wire which is continuously feed into the system. Or generation, an electric arc is generated between the wire and the workpiece. So here the metal is deposited layer by layer by melting the material. So the entire process is computer controlled. So it is otherwise called as wire arc additive manufacturing or gas metal arc welding system, or GTAW, that is gas tungsten arc welding. So let us see a video about the process. So we can clearly see that the robot arm is only thing that welds the required geometry. So here the type of material we can see here clearly that titanium, aluminum and steel are used. Titanium it is for the high strength to weight ratio. The aluminum is for the light weight ratio and also for corrosion resistant. Steel is versatile and strong. So these are the different types of materials that can be used in the wire arc additive manufacturing. So the material properties is the high strength to lightweight, and there is a limitation like susceptibility to oxidation. As I told you earlier, the gases may react with the environment, so that there is a chance of uh, having a oxidation. So in order to avoid the shielding gas is used, so which may cost high. So this is the difference or the comparison between the wire arc and the traditional manufacturing process. In wire arc, there use of electric arc to melt and deposit metal wire by layer. So in the traditional manufacturing, shapes through material by cutting or molding or casting process. So the material usage here is the wire form of material. It is melted and deposited over the layer by layer. And here it is a solid shaped material through various methods. And the flexibility, it allows complex geometries without mold. Whereas in traditional manufacturing, there is a limitation on the mold because we cannot achieve all kind of profile in the mold. So there should be a application of CNC machine in order to get the required geometry. So speed and efficiency, when compared to traditional manufacturing, this wire arc additive manufacturing is a modern process where it uses the robot arm. So it is a faster and it can generate complex profiles or it can create complex prototypes. So the production rate is also high. Whereas this traditional manufacturing, the mass production is can be efficient by optimized methods. So here, both the methods are used in all kind of applications, especially the wire arc is used for aerospace application. So coming to the cost of the process is high but economical for customized parts, whereas the tooling cost is high in mass production for the traditional manufacturing. So these are some of the components of different varieties such as aluminum, titanium and steel. You can see here. So this is the aluminum, steel, magnesium, titanium, nickel, copper alloys that are manufactured using wire arc additive manufacturing.